Now I'm going to teach you how to do the abbreviated method for electron configurations. And this one's a little bit quicker. So we have different kinds of electrons. So the electrons that are in the full electron shells are called core electrons. The electrons outside the core electrons are called outer shell electrons, which include the valence electrons. So because the core electrons are not available for bonding, we can do what's called an abbreviated method. So if you look at the periodic table of the elements and find the noble gases, those are our core electrons. That's at the end of each of the electron levels. So at the end, the first one, at the end of the first principal energy level is helium. You might want to mark this on your off-ball diagram. So that's the end of the first principal energy level. Then all the rest of the noble gases fill out this P shell. So at the end of 2P is neon. At the end of 3P is argon. At the end of 4P is krypton. At the end of 5P is xenon. And at the end of 6P is radon. Those are the only possibilities for cores. So how you do this is you look for the previous noble gas. You do not go forward, you only go back. So what you can do is, let's do calcium. Put your finger on calcium on the periodic table of the elements and run your finger backwards until you hit a noble gas. And the noble gas you hit is argon. Argon is at the end of 3P. So all of these electrons in brackets belong to argon. So how I can do the abbreviated configuration is for calcium, is to put the core in brackets and then put the outer shell electrons outside of it. This makes it a lot quicker. So we can double check ourselves. Argon is 18, calcium is 20. So the core has to be less electrons than the atom. I can also double check myself that the electrons in brackets add up to 18, and they do. So all 18 of the electrons that belong to argon are inside these brackets, and I have to represent 2 more. Now let's do arsenic. Find arsenic on the periodic table of the elements, run your finger backwards. Again, you end up at argon, like such. So those 18 electrons that belong to argon will go in brackets like this. And the outer shell electrons still need to be represented. So arsenic is 33, argon is 18, so we still need to represent 15 more electrons. Now these are all outer shell electrons, but still the 4s and the 4p are the valence electrons for 5 valence electrons, and the 3d are outer shell electrons, but they're not valence. Let's do indium. Back your finger up, and when you back your finger up, you're going to bump into krypton. So krypton here is at the end of 4p. So I can look for 4p in here, like such. Now, when I put krypton in brackets like this, all 36 electrons that belong to krypton are now inside the brackets represented with Kr. Remember, you can only use noble gases as a core. And then I'm going to put the outer shell electrons next, like such. Again, the valence electrons are 5s2 and 5p1. 4d10 is outer shell electrons, but not valence electrons. Let's do one without the complete electron configuration in front of us. So let's do barium. Barium is 56. So if you run your finger backwards till you hit a noble gas, you're going to hit xenon. So I put xenon in brackets, and when I do that, I represent all 54 of xenon's core electrons. So inside those brackets is 54 electrons. Barium has 56, so I only need 2 more. After xenon, we can go to our Aufbau diagram if we want. After xenon, so all of these electrons are inside the brackets, like such. Those electrons are all inside the bracket. And next, after 5p, I go to 6s2. How about scandium? Scandium is number 21. I'm going to back up until I hit a noble gas, and it's argon. So I'll put argon in brackets. That's 18 electrons. And then I have, after argon, after 3p, I have 4s2 and then 3d1. So scandium has 21, argon has 18, so I have 3 more electrons to represent, and it's 4s2 and 3d1. My valence electrons for scandium are the 4s2, and then my outer shell electrons are both of them together, 4s2, 3d1.